We have talked about urban agriculture, natural solutions before, and this was the figure we looked at when we did, I think, chapter 16 about enhancing carbon sinking into natural and working land. So just to touch on them again, this is a global scale. So these are the 20 natural pathways that were proposed with their climate mitigation potential in terms of petagrams CO2 equivalent per year additional being taken up. So reforestation, so it was split into forests, agricultural and grasslands, and wetlands with various options within them. Maybe I won't go through all that again, but there are also co-benefits like air quality, biodiversity, water quality, soil health, and so on that we talked about. But more excitingly, the paper also argued that if you look at the historic emissions and future scenarios, this was from 2016 or so, business as usual would take there, and we have been talking about bending the curve, but natural climate solutions would give us additional room for bending the curve to stay here below the 2°C warming target. So obviously have great potential and benefits and co-benefits. We have to bring that into the localization context. So this has been done specifically for the US as well. So this is looking at the natural climate solutions for the US in terms of climate mitigation potential by 2025 in teragrams CO2 equivalent per year, and it's showing maximum and various other targets like $100 megagram CO2 equivalent. So it also puts a cost on these things. So you can see maximum potential is quite good, but you have to worry about these other costs as well. Okay, again it splits the solutions, natural climate solutions, into the same baskets: forest, agricultural and grasslands, and wetlands. But when you do it more specifically for a country, it's obviously good to have a sense of the potential for reforestation as well as managing existing forests and avoiding forest conversions, doing urban restoration in terms of trees and leaf cover, wildfire management, and improved plantations, as well as here land use conversions, cover crops, biochars, alley cropping, cropland nutrient management, windbreaks, so with even things like agroforestry that can work, livestock integrated management with grazing optimizations, and legumes in pastures, nitrogen soil nitrogen sequestration, as well as reducing the impact of grazing on pastures, and of course wetlands, peatland restoration, and so on and so forth. Avoided seagrass loss is also a big thing, especially for a place like Chesapeake Bay. So restoring seagrasses also then becomes important, especially if you go to places like Gulf of Mexico, which have destroyed the natural defenses over time and have become much more vulnerable to hurricanes with sea level rise and local warming of the Gulf of Mexico, steric rise, etc. Plus the impact of more intense hurricanes that are moving slowly and stalling near the coast, etc. So all kinds of multiplier effects from climate are adding up on top. Okay, so this is the concept that is now more specific when it comes to natural climate solutions. Urban agriculture and food forests. So you can see here food forest planting on the OVGG that we looked at in Southeast San Diego. And you can see the various age groups, obviously community and students. I think these are all community people, if I'm not mistaken. And a neighborhood scale food waste to soil and energy system operating on the UCSD campus. Okay, so what is a food forest? It's basically a gardening technique or land management system which mimics woodland ecosystem by substituting edible trees, shrubs, perennials, and annuals. So you grow a forest, but it's made up of things that can be locally used. Okay, this is from the Beacon Food Forest co-founder Glenn Herlihy. Okay. So interesting idea, especially when you do it as rooted place-based solution with climate engagement. So meets all the definitions of things we have been looking for in terms of bioregionalism and localization. Neighborhood scale microgrid food to waste to soil and energy systems. So you collect the waste in these biodigesters. So this is the tour of anaerobic digester at UC San Diego. You definitely see students here standing and listening to somebody speaking. So we talked about biodigesters, anaerobic respiration producing methane for energy and using the residues to then convert into soil, or food waste also going into soil composting techniques and so on. So this is a living laboratory, right? This is great for education, for using community food waste to convert to soil and energy. So community engagement also makes the university a rooted university, which we will look at as a concept. So fantastic ideas that are actually being implemented in California. So wouldn't you love to go learn or work in those places? I would, especially if you have good friends in places like La Jolla, which is a fantastic place to visit. And I hope my friend Art Miller will invite me one of these days after this COVID business is over. Hi, Art.